So of course, with logical operators, you can chain together expressions to create really complex Boolean expressions. So here we have four Boolean values, four Boolean variables. Um, and then we chain them together into, we have a statement here, right? An expression here with and. We have another and expression. And then these two and expressions, which are expressions themselves, are chained together with an or. And then altogether, it's one big complex Boolean expression. So at the end of the day, these little expressions are true or false, and then the big one is either going to be true or false, right? Boolean, true or false. That's the only thing it can evaluate to. So like in math, right, you might typically start with the inside of parentheses, right? You might go on the furthest parentheses here, the most nested parentheses, and start working with face match, maybe then compare it to is owner, and then do pin entered, and then screen on. And that would certainly work, right? You could just go left to right. Of course, you'd have to go left side first, right side, and then the or operator, right? Because the OR operator is on the outside of these two. So think of this as, you know, X and Y. You have to figure out, is X true? Is Y true? And then you could do the OR of X and Y. And as with OR, as we know, right, only one side has to be true. So typically when I'm reading these, I like to look at, yes, the furthest most operator, the one outside of all the parentheses, and I can see that it's the OR operator. Now, why do I like to do this? Because this is how I can determine, how much work it's going to take to solve this expression. The OR operator is good news for me because all I need to do is find one side to be true, right? If it was an AND operator, that's also kind of good news, right? Because I only need one side to be false for the whole thing to be false. So different operator, right? Different situations. So for the OR, as long as one side is true, the whole thing is true. So I'm gonna start. Let's see. I could either pick the left side expression or the right side expression. Let's go with the left side. So we have face match and is owner. So this is a little mini expression. Both of them have to be true for the left side to be true. So face match and is owner. Let's check. Face match false. Oh, already. With the and, I already know things got to be true anyway. So I'm going to put a little X there. So this whole left side already evaluated to true because face match was false. Or sorry, this whole left side evaluated to false because face match was false. Is owner was true, right? But remember, with the and expressions, really both have to be true. So as long as you find one that's false, the whole thing is false. So this is the left side. Left side is indeed false. Okay, now let's try the right side. So again, thinking positive. Not that it always has to be positive, but I always like to think that way. So thinking positive, I'm gonna hope that the right side is true. All right, so I'm gonna check one at a time. Let's see, pin entered. So pin entered is true. And because I have an and expression, in order for the right side to be true, screen on also needs to be true. I can see screen on is true, so that means the whole right side is true. So I'm going to circle it. Let me change colors. Let's go green. So yeah, the right side is true. Well, what do I mean by left side, right side? Well, remember, my or is in the middle. So as long as one side of my or is true, then the whole thing is true. Well, the right side of my or is true, so the whole expression turns out to be true. So yeah, I kind of split it up into multiple slides if you're on the slides. But yeah, we'll go step by step if I went a little bit too fast. So yeah, this expression chains multiple values and conditions together using and or. If the whole expression is true, the user's phone will be locked and secured. Or it should be unlocked, I should say. Bear with me for a sec. Okay. So yeah, does the condition inside the if statement evaluate to true or false? Will the phone be unlocked? So we start with the logical or since it's on the outer part of the expression. The entire condition will be true if either side of the or is true. So now we start to dig deeper, right? We're starting on the outside, digging our way in. So let's check the first the left side of the or. We found out that face match is false. And I don't want to confuse y'all by using the ampersand here. I'm just going to write out and. So I'm not talking about any logical operators there. Yeah, just like to make a little bit of a tweak there. Okay, so let's continue. So yeah, let's first check the left side, which says face match and his owner must both be true because we have an and. But we already know the left side is false because face match is false. So we didn't satisfy the both true. So already we can slash out the left side. Now we got to go to the right side of the or. So we're going to check pin entered and screen on because we have an and there in between them. They both have to be true. Well, pin entered is true and screen on is true. So right side turns out to be true. So pin entered and screen on are both true. This means the whole expression evaluates to true. Only one inner expression needs to be true since there is an or in between both sides here. So yeah, again, we could definitely do it one more time just to kind of hammer it home. So face match was false, so I'm gonna put a little X. Is owner is true. And I'm just gonna go left to right. This is another strategy you can do. And then kind of work your way up. So pin entered is true, screen on is true. So now I'm gonna check the group, right? So face match and is owner. For and, they both have to be true. Now let's check the other expression. Pin entered and screen on, they're both true. So then we get a true here. Whoops. Wrong symbol. I thought I clicked on the check mark. True. So now the or says, as long as one of these sides is true, then we're good. I can definitely see that the right side, I got my check mark there. So then the whole thing becomes true. And yeah. So yeah, this if statement would execute. And theoretically, right, the phone would be unlocked in this scenario. So yeah, that's complex expressions. Here are some tips. You could start with the parentheses to evaluate grouped expressions first, just like math. We're going to talk about short circuiting in a sec. So you can use that to your advantage. Remember that and stops early if the first part is false. So as soon as you find a false in an and expression, whole thing is false. If you find a true in an or expression, whole thing is true. So again, different logical operators, different situations, different things to look out for. Check the simplest or most likely condition first to avoid unnecessary work. We'll talk about that more in short circuiting. Break long expressions into smaller parts using temporary variables for clarity. Just like I represented them, right, in those groups, you could name those groups, right? And rather than writing a really long expression, you could break up face match and is owner as like a variable on its own, right? You could have a fifth variable equal to the expression right here. So that by the time you write your if statement, this is much shorter. So let me show you all what I mean by that. So let's pull out my IntelliJ, shrink this a bit. All right, so I have my variables, right? So I have my Boolean face match equal to false. I have my Boolean pin entered equal to true. Boolean is owner equal to true. Boolean screen on equal to true. And then if face match. And so it gets really long, right? Is owner. And that's kind of my point. So rather than writing all these variables put together, which can get very, very long, let me do system.out.println. Oops. Rather than doing this, I can make a fifth variable. I could do Boolean authorized user. Might not be the best name, but right, we'll go with it for now. Definitely put a lot of thought into your variable names when you're writing out programs because again, even better than comments is writing good variable names. If you write good variable names, you don't really even need comments sometimes. So authorized user would be face match and his owner. And usually when you have these expressions together, always a good idea put a little parentheses. I like to do that just for readability. So what I did here, right, is I created this expression as a variable. So now rather than writing this really complex looking expression, I can just write or replace it with authorized user. And I have another expression to the right, pin entered and screen on, right? I could do the same thing. Boolean uh, pin enter, or sorry, we're going to say, so pin entered screen on, we'll say authorize, I don't know, hardware. Again, might not be the best name. We're going to say pin entered and screen on. And again, rather than writing out pin entered and screen on so that my expression gets really long, I can write out or authorized hardware. And boom, I just simplified a really complex expression there. It's the same expression, right? I'm just using placeholders. And this is where variables really help for abstraction. So that's representing different things. And also just for making things simple to read, right? So rather than reading that really long expression, 100% right, this one's a lot easier to read. And if I had questions about what authorized user meant, I would just go to the variable and see, okay, what has to do with these other Boolean variables, and I can kind of peel back the layers. So yeah, this is much better code than the one here. Just keep that in mind. So yeah, that's how you could definitely solve complex expressions. As a coder, right, it's just better to break them down into variables. So this is one of the examples, right, where variables are extremely useful in programming. And again, if I wanted to use this variable 100 times more, right, I just have to call authorize user. Imagine having to write this out 100 times. It would look really messy, very long, uh, and it would just be hard to evaluate in my head, right? Rather than just reading authorized user. So yeah, that's how you could definitely simplify your expressions. So yeah, use meaningful variable names to help you mentally read the logic like a sentence. Again, even better than comments are really effective variable names. So trace with sample values to step through each part and verify the outcome. Yeah, so when you are writing these and designing these Boolean expressions, it's a good idea to like test different values out to make sure that the logic actually pans out to what you want it to be.